All right, let's do another trigonometric function, evaluating a trigonometric function. I'll take this moment to emphasize that, this cotangent is a function. The input is an angle, right? The input is an angle, and I know we mentioned this in class. The output, when the angle that we see here, okay, the output is a ratio of coordinates, right? In this case, we'll say the output is coordinates. And I have to backtrack just a second because when I was talking about this video, I was saying anytime you're asked to do one of these reciprocal functions, and I said secant, cosecant, cotangent, you should do its reciprocal first and then flip it over. Cotangent is kind of an exception to that, right? So let me just say with secant and cosecant, it's best to do cosine and sine and then flip them over. But whether you do tangent first and then flip it over, do cotangent, you're fine just finding cotangent of one of these angles instead of doing tangent and then flipping it over, because tangent and cotangent are both fractions of x over y or y over x anyway. Hopefully that didn't confuse you even more. When we're finding cotangent of 21 pi over 4, again, I've brought the unit circle out because where is 21 pi over 4, right? It's not labeled, but it's here. So go off to the side and determine what the coterminal angle is for 21 pi over 4, right? Much larger than one rotation, right? One rotation is 8 pi over 4, okay? So we're obviously going to have to subtract 2 pi. But before we even do that, let's think, number sense, common sense, mental math. One rotation is 8 pi over 4, which means another rotation is another 8 pi over 4. What is that? That's a total of 16 pi over 4, which still 21 pi over 4 exceeds that, right? So if we made another full rotation, that would be 8 pi over 4, 8 pi over 4, 8 pi over 4. That's 24 pi over 4, which is bigger than what we're looking at. So find that sweet spot where we can subtract 8 pi over 4, but then we're going to have to do it again. So instead, think about subtracting what amounts to be 2 rotations of this angle of the unit circle, and we would end up with 5 pi over 4. So in other words, 21 pi over 4 is 5 pi over 4. Okay, so finding the cotangent of this is the same as finding the cotangent of 5 pi over 4. We can use the coterminal angle for this. All right, and 5 pi over 4 is down here. Right, you're going to have this unit circle either embedded in your brain or on a sheet of paper in front of you or in a web page, right? A bookmark. So let's use it, right? The cotangent of 5 pi over 4, if you recall, cotangent of theta is x over y because tangent is y over x, right? So we take the x coordinate, which is radical 2 over 2, and the y coordinate, which is negative radical 2 over 2, and rather than taking that second fraction out and multiplying and doing all that, just recognize that it's the exact same value in the top and bottom of this big fraction. So because this is the same as this, the overall value of this cotangent is 1. Okay. And just as a side note, any reference angle of pi over 4, right? When you're doing cotangent and tangent of these angles, it's always going to be some variation of a positive or negative radical 2 over 2 over radical 2 over 2, whether it's cotangent or tangent, right? So long story short, cotangent and tangent of pi over 4 angles are either going to be positive 1 down here in quadrant 3 and quadrant 1, because positive over a positive is positive, negative over a negative is positive, or it's going to be negative 1 in quadrants 2 and 4, right? Because one of those values is negative. So keep that in the back of your head anytime you're doing a tangent or cotangent of a pi over 4 angle. Any other function of any other angle is gonna include some variation of a radical or something like that. Okay.